All right, let's talk about Kubernetes security. Kubernetes is basically the engine that runs the entire modern cloud. But all that power, well, it comes with a pretty serious challenge, figuring out how to lock it down. So today, we're going to dive in, explore why this is such a critical skill, and build a really simple mental model for how you can protect it layer by layer. And this quote, it just nails it. Kubernetes isn't some passing trend, it's a fundamental shift in how we build and run software. Honestly, in today's cloud world, trying to avoid it is becoming pretty much impossible. And I mean, just look at the numbers. They're absolutely wild. 77% market share. That means Kubernetes has become the de facto, the operating system of the cloud. It's not just a popular choice anymore, it's the standard.
So what's the big deal? What makes it so dominant? Why is everyone calling it the new cloud OS?
Well, the secret sauce is just its raw power and its incredible flexibility. It was literally built from the ground up for the kind of complex, sprawling applications that run our world today. Think about companies like Uber or even Goldman Sachs. Their massive systems depend on this kind of architecture, and Kubernetes is the thing that makes it all work without falling apart. But, and this is a big but, here's the catch. With all that amazing power comes a ton of complexity, and that complexity makes it an absolute beast to secure. Let's just look at a couple of the core pieces to see what I mean. First, you've got the Kube API server. The best way to think about this is like the main gatehouse to a giant medieval fortress. Every single command, every request, every little change, it all has to go through this one single entry point. It's the brain, the control tower, the whole shebang. And what's inside that fortress? Well, that's where your applications live, and they run in these things called pods. A pod is the smallest thing you can deploy, and it holds the containers that are doing all the real work. So in our fortress analogy, these are like the individual buildings, the barracks, the treasury, the houses, all the important stuff we need to protect. So you can see where this is going, right? You've got a central gatehouse, dozens of buildings, all these complex rules, and suddenly you have a massive surface for potential attacks. One unlocked door, one tiny little misconfiguration, and the whole fortress could be compromised. And this isn't just some theory. Let me tell you about a time this happened for real. So a few years ago, some attackers targeted a Kubernetes cluster that was being run by, Tesla. But they weren't after secret card designs or anything like that. They wanted something much, much simpler. And how did they break in? Some crazy, sophisticated zero-day exploit? Nah, it was way simpler than that. They basically walked right in the front door. The attackers found a Kubernetes admin dashboard that had been left exposed to the internet with absolutely no password. It was literally the digital equivalent of leaving the keys to the kingdom under the doormat. Once they were inside, they unleashed their payload, crypto mining software. They just hijacked all of Tesla's powerful cloud computing resources and used them to mine cryptocurrency for themselves. It's a perfect and kind of scary example of how high the stakes are. One simple mistake led to a major and very public breach. So, how do we stop something like that from happening to us? Well, it all starts with locking the front door. We've got to secure that API server. That's always going to be your first line of defense. Think about it this way. Every single request that comes to that fortress gate, the API server, has to go through a 3-step security check. First up is authentication. The guard at the gate asks, "Who are you?" and checks your ID. Simple enough. Next is authorization. The guard looks at a list and says, "Okay, I see who you are. Now, what are you actually allowed to do here?" And finally, there's admission control, which is like the guard inspecting the cargo you're bringing in, making sure it follows all the rules of the fortress. And that second step, authorization, is usually handled by something called RBAC, Role-Based Access Control. This is the official rulebook for our fortress guards. It's all built on a core security idea called the principle of least privilege. It just means that even if you have the right ID to get in the gate, you can only go into the specific rooms you absolutely need for your job. No wandering around, no peeking into the throne room. You get exactly what you need and nothing more. Okay, great. So we've secured the main gate. The front door is locked. But what about all those buildings inside our fortress? We have to make sure the applications themselves, our workloads, are also secure. And for that, there are 2 key preventative steps. First, there's image scanning. This is like having a safety inspector check all of your building materials before you even start construction. It scans your code for known security holes.
Now, the second big idea here is enforcing security rules at the cluster level. And, this slide mentions pod security policies, but I should point out that those are actually deprecated now. The modern way to do this is with something called pod security admission, but the idea is exactly the same. It's like a building code for our fortress. It sets strict rules for what a running application is and is not allowed to do, like preventing it from getting super user privileges it doesn't need.
But let's be realistic. Even with the best gates and the strictest building codes, a clever threat might still find a way inside. So our final layer of defense has to be runtime security. How do we spot an active threat that's already past the walls? A really awesome open source tool for this is Falco. To stick with our fortress analogy, Falco is like a network of security cameras and guards patrolling the grounds 24/7. It plugs right into the operating system and watches every single thing that happens. Every file that's read, every network connection that's made. It then checks all that activity against a set of rules to spot weird, suspicious behavior in real time. And these Falco rules can be so powerful. For instance, you could write a rule that says, hey, if one of my web server processes ever tries to read the sensitive password file, sound the alarm immediately, right? A web server has no business doing that, and Falco is built to catch exactly that kind of shady behavior instantly. So when Falco does sound that alarm, what's your next step? Well, you have to investigate. And that is where Kubernetes auditing comes in. This is the Fortress's official tamper-proof logbook. It is a perfect record of every single action taken in the cluster. It answers those crucial questions for any investigation. Who did what? When did they do it? And from where? For any kind of security forensics, it's absolutely essential. So we've looked at all these different layers of security. What's the big picture here? What's the main takeaway? The takeaway is this. Kubernetes security isn't about finding one magic bullet, one tool or trick that fixes everything. It is a defense-in-depth strategy. You need multiple overlapping layers. You have to lock the gates with strong authentication, you have to harden the buildings with things like image scanning and security policies, and you absolutely have to patrol the grounds with runtime detection and auditing. All three are critical. And that really brings us to the final big question. Security isn't something you do once and then forget about. It's a constant race. And as Kubernetes becomes the bedrock for more and more of our digital world, the challenge for all of us is, how do we, the defenders, keep evolving our strategies to stay one step ahead of the attackers? That's the question we all need to be thinking about. Thanks for joining me for this deep dive.